Smart infrastructure, I kind of look at it as having two levels. One is the component level and one is the system level. So for example, if you look at the component level of infrastructure, that's going to be looking at a specific bridge, a specific roadway, a waterway, levees, dams, that sort of thing. The idea at the component level of smart infrastructure is that you are examining the behavior of that component by either placing physical sensors on the bridge or doing this indirect monitoring with a camera or a smartphone and taking data from that structure to learn what is happening to that physical component in the field. The system level then is really the interaction of those components. And so really, if you're going to achieve what's called smart infrastructure, you need to have a platform or a framework of a lot of different sensors working together to monitor these systems while considering subcomponents of that system. Specifically, we are looking at collecting data from passenger cell phones traveling over bridges in vehicles, looking at data signatures coming off of those cell phones, including acceleration data, to try to determine the effect of the vehicular traffic and damage on the bridge's behavior. So we're looking at small changes in the vibration characteristics of the bridge to try to back out if the bridge is behaving nominally.
If we're wanting to leverage crowdsourcing as a post-processing technique, we obviously need a large number of vehicles to drive over bridges. And if we're able to use smartphones, which contain an accelerometer among other things that can record vibrations, say 10 different vehicles that all drive over the same bridge, they'll have different frequencies that are dominant all over the place depending on the vehicle, but the one frequency that they'll all have in common is the bridge. And so if you average all of those together, what we would hope to see is one large magnitude frequency right at the bridge frequency, and then everything else is just kind of lower order stuff.
Data we've gotten from smartphones that we've run over this testbed bridge in Garland has actually given us a lot of insight into the types of data that we should expect to see on the bridge. When you get out in the real world, things like surface roughness of the road profile, suspension of the vehicle, characteristics of the different frequencies that you get out of that suspension of the vehicle become very clear. What it does is focus our analytical efforts to try to highlight key characteristics that are going to be important as we're determining the health of the structure. We need to make sure that it operates in a way that is safe for the public. So one of the ways that we're hoping that this research will address that issue is having an affordable, efficient way to monitor these bridges without having to go and expend tremendous amounts of time, money, and energy instrumenting every single piece of infrastructure. If we can develop techniques that are able to rapidly assess multiple structures, then we can do this monitoring in an efficient way. We can start to look at the system, the civil infrastructure system, in a smart and efficient way. What I'd love to see is having some of these systems built when a new bridge is constructed, having some sort of monitoring system, even if it's as simple as a camera or a few accelerometers, built with the initial construction of the bridge. That would give us a tremendous baseline of data that you don't usually get from an existing structure. It would be great to be able to monitor the structure from the first day that it's in operation.
The data we collect from maybe the first iteration of smart infrastructure can be used to figure out, what worked, what didn't, what can be optimized, and then additional smart infrastructure that we build going forward, all of that can be taken into account. So we're continuously using smart infrastructure to improve the next iteration of smart infrastructure.